where we see the threats, certainly from our peer competitors. But we also see, again, the taxpayer dollar is something that's pretty precious that we need to get that bang for the buck. So why modernize? In 2012, I'll take you back to the budget fight. You know, we had sequestration come out, and the Army looked at it, and we felt like we had counterinsurgency for that's all that the future really had for us as far as a problem set. So kind of the Iraq and Afghanistan model and extremist organizations fighting them. And then the Russians really woke us up when the Crimea went down, and especially when a number of their engagements with the Ukrainian forces in the Donbass, they were very lethal. They were very quick with their lethality. And we looked at that over the last 7 years or so, and we wanted to be able to ensure we could match that, again, just for the deterrence aspect of what we had learned during the Cold War. And so coming out of that, we said, well, those studies, well, if we have our 40-year inflection point where we're going to modernize, we're going to do four things. We're going to do, and that's the top left quadrant. We're going to do a future attack reconnaissance aircraft. We're going to accomplish a future long-range assault aircraft, and then we're going to do our unmanned work. And then the last thing is, and the hardest thing we're going to do is we're going to do a modular open system architecture or an open system approach. And I'll get into why that's going to be the hardest thing we do here as I go down the list. Again, if you look at our current fleet, it's all been designed in the 50s, 60s, or 70s, so during an analog age. And as we look at some of the threats that are emerging from our competitors, namely China or Russia, but even others, Iran, North Korea, those kind of folks, when we have a capability that we want to integrate onto our current fleet, we're either stymied by lack of terrain on the aircraft to put it in, or we're stymied by the folks that have the original equipment manufacturer that have the intellectual property locked down. And so I won't name competitors, but if we just want to change the cursor, how that size and shape looks in our cockpit, you know, just to open up the IP is a $10 million just to start the discussion. And the Army's very tired of that kind of being wed to one equipment manufacturer. And our fleets last for 50, 60, 70 years. So getting hit by those costly upgrades, but they're also costly in time. And what we've seen is we haven't been able to turn inside of our potential foes as they turn inside us with a number of things that are very ingenious and hurt our program's capabilities on the field. So this is why we need a clean sheet design. This is why we need to enter in the digital age and have a digital design and all the benefits that come from entering the digital age. We are a service, just to give you scale, is we have more medevac aircraft than the Marine Corps has aircraft. We recruit the size of the Marine Corps every year into the Army. So the Army is very large in scope and scale. The nation asks us to do a number of things. We wrote all the contracts for all the COVID vaccines. Those were our folks that did that because, again, we just have an army of folks that can get after some of these big things. The future attack reconnaissance aircraft, we view that as a capability that can find and fix threats on the battlefield. And our future long-range assault aircraft would be our troop transport and our medevac aircraft. Those two aircraft, again, in this digital design environment, we really think we can capture the deflationary nature of technology. And for the data scientists in here, these present a rich place to help us with our maintenance. 70% of our life cycle cost of these two aircraft is going to be in our operational and sustainment areas. And that presents, again, a very rich target to be able to pull that left even a few points, or if we're able to even do more, it's really a cost savings. And we feel like, again, in the digital environment, we can do that. The prototypes that you see in the middle there, the one on the right, the tilt rotor, it went together first time ever. And we had 5 different performers building parts of that airframe. In this digital thread and digital design environment, it went together with only 3 shims. So those shims line up the holes. We only had 3 holes that were misaligned on our first go. Our Black Hawk helicopter today, hundreds of shims still required after building it for 50 years because the analog age didn't give us the precision we needed. And that leads to vibrate. I mean, there's all kinds of downstream effects to those shims in making them harder to maintain and harder to be ready. The 4 tenets that we see in our 2 aircraft is we want them to be have the reach of an Indo-PACOM theater. And what do I mean by reach? It's a combination of speed, range, and endurance that's transformational from our current fleet. And these configurations you see here, the reason we call it vertical lift and not the helicopter guy is these are not helicopters. They're hybrids and that hybrid nature of it allows us to get more efficient and fly farther and fly faster. We obviously also want them to be survivable. And so there's a number of systems out there on the battlefield that are fairly low cost that our enemies and potential enemies work very hard on, that we want to be able to blunt that kind of asymmetric cost advantage that they're pointing at us and be able to be survivable on the battlefield. And then obviously we want to be affordable. So you notice we're doing 2 at the same time. I get a lot of criticism in DC, on the Hill, in the department. Why are you doing 2 when in the 90s you couldn't do 1? And I would say with that, we've looked very carefully at our affordability. It's somewhat Rugen dumb luck. So my dumb luck is we are buying out our fleets this decade. Our current fleets are done. And so that buyout gives us the headspace to basically pursue the future. We're not buying our current fleet because we bought all we need to, and we can jump to the future. And it's very much how we came out of Vietnam. Our current fleet was modernized. That modernization allowed us to get the Black Hawk and Apache that you see today. And a number of external agencies have agreed with that parametric to include the Congressional Budget Office, which they're no slouches, and 2 think tanks, the CSIS, Center for Strategic and International Studies, and CSBA, the Center for Strategic Budgetary Assessments, both in DC. And so that's why we're doing 2. Obviously, the next thing is our unmanned systems. We really want a transformation in our unmanned platforms. Put it very succinctly, we want our unmanned platforms to do the dangerous, dirty, or dull work. And so where we see a trained soldier has a problem is in a dangerous situation where we don't want to lose a life. And that certainly is the American military's way of thinking. We're going to put something out there that has the standoff, that has the capability to fight it appropriately and not endanger our soldiers if we don't have to. The dull work is just that constant stare. And again, we feel the machine can do better at that constant stare. And then the dirty work, just think chem bio or nuclear radiation kind of environments where we can put something in that can assess the situation and come back to us with data, so we don't have to, again, expose our troops. And then lastly, the modular open system approach. And so again, I'm a operational guy. I'm not an acquisition trained officer. I've been in cockpits most of my 32-year career, and I've been on operational units most of my 32-year career. And so what we want, my stupid analogy is we want an Android phone. You know, we want it open to everybody. We want to give centers like this and others the government-defined interface, the government-defined standard, and then have that standard be viable with a set of digital tools that the government doesn't manage, because it'll become stodgy and old, and you know, our resourcing is very fits and starts. And so those 2 things allow third-party applications to then come into our aircraft. And again, it's Android-like, not necessarily Apple-like. Apple owns their IP, they're closed. a bit on the app store, and we want to have far more open when it comes to third party. In some of our Western test range work, the iconic Gray Eagle, kind of our Predator aircraft, we've put 20 technologies onto and off of that aircraft over the last 2 years without talking to General Atomics, the original equipment manufacturer. So we don't have to go and ask them to put a mission system capability on, because we fractured that internal aircraft OFP from our mission systems. And now we have gateways that can talk between the two, but we own that as a government. And academia has been instrumental in allowing us to do that. Again, to put some competition in the space so we're not tied to an OEM for life. We have a depth and breadth of studies. I'm up to over 25 across these 4 lines of effort that we're doing. The studies really get after, are we effective against our pacing threats, and are we affordable? So as I mentioned, the Army has massive scale. The Future Long-Range Assault Aircraft will be the biggest program in the Army because we just have so many of these aircraft. So currently, our requirement is 2,135 Blackhawks, and this is going to replace the Black Hawk. And when you think of that scale, we have to ensure we're affordable. We cannot really go down the path of F-35 that we need a few of these things and we can, really charge a premium and have a lot of very complex boutique technologies. So we're looking again at getting help from a number of experts on keeping things affordable. What is the viable path? And that will be extremely data intensive to say you have something that's viable. Let's flow with that because it keeps the Army under its cost caps. This reduction in operations and sustainment, this is really where our lash up with Dr. Maddie and our AI2C folks out of Carnegie Mellon has been huge, because we have mountains and mountains of data on our current fleet, and we can't really see ourselves with all this data. What are the crown jewels hidden in that data, where some data analysts or some program could say, if you concentrated in these 2 or 3 areas with this data, you could take your part that you have to change out every 2,000 hours, that's very expensive, and we may be able to figure out how you could change it out 10% later, 15% later, 12% later, or have the sensor suite be, that part is about to fail and you don't want to hurt anybody, so let's alert you, and it's well before the time when you would normally change it out. That's just one of our biggest use cases. And again, we have a ton of data, and we have this concept that we want accomplished, but the people we have to prove it to are our airworthiness authorities. And the Army has an army of folks, and their heart is in the right place, to where we don't want to fly things that are dangerous to the troops in the back or any of the mission sets that we have. So we're going to have to prove to them through data that we can move some of these mandatory swap outs around. We get into our lethality and survivability, and I think here again we're looking at AI use cases, and not to scare everybody too much. I mean, obviously we want to be a deterrence to any future enemy, and so when we come into academia, we're sensitive to talking about lethality. But how I look at it is, if we can deter, that's the ultimate reason why you want an armed forces, is to never fight. And then what's more expensive than deterrence? Probably fighting a war. And then what's more expensive than fighting a war is losing a war. And so that's how I parse it. And again, that's why our lethal capabilities are important for everyone to take a look at. I also think the value proposition to some place like this is, you're going to want to shape the AI policy. You're going to want to help the nation come up with a policy on the use of decision agents on the battlefield that is married to our culture, and we're going to need help with that. Do we want decision agents that we just send out there? Because in our Army, we fire a capability not on identify, but identify, or not on detect, but detect and identify. So we always are going to identify our target. I would tell you that our enemies don't do that. They fire on detect. And so we're going to need to match that speed with better tools, because I don't think we're ever going to go away from firing on identify. And this is, again, where AI is going to be crucial to that speed on the battlefield. Going up to the rightmost quad, portion of the quad, what are we doing with all those studies and then our 4 lines of effort? We've put this ecosystem into a high fidelity physics-based model. We've fought the Russians in it. We've fought the Chinese in it. And we've done that over about 100,000 engineered runs in a massive model. What that has spit out to me is a refinement of my requirements. And as I've refined those requirements, I've taken now the 4th time in as many years, gone out to the Western test ranges and fought these new concepts and new technologies against live threats and live threat emitters at China Lake, currently at White Sands Missile Range, Yuma Proving Ground, and Dugway Proving Ground. And what we're seeing is the efficacy in some of our thinking is resonating. It's resonating with our folks at the Department of Defense, and certainly on the Hill at Congress, and the folks that I have to basically outbrief our portfolio to. We're also very much in tune with soldier-centered design. So we've had soldiers from every rank that currently touch our aircraft in any form or fashion out to give us feedback early. And that early feedback has also informed the design to make sure, again, we're going to build something that's useful and easy to use to our soldiers. And I'd like to give you just a little vignette. You know, if you talk to our current fleet and our current Army troops, they've had to go out and if we've dropped them on a target, they've had to, and a lot of it is in a chat box, chat back to some unmanned pilot, the pilot that's flying their unmanned vehicle, and very maybe while there's rounds or things exploding, maybe a very complex environment at night, very dusty, with maybe some wounded around or whatever, very kinetic. They've had to type, hey, you know, move it over here, or hey, can you point the sensor over there? And as you can imagine, that voiceover in a text box is probably not clear. It's probably not precise. And again, the latency baked into that fight that you can imagine allows us to maybe be not as effective as we could otherwise be. What we did out at Dugway this past May was basically, you know, gave a tablet to the lieutenant who was on the ground. We had flown him in or assaulted him into an objective. And he was able, with a tablet and a level of interoperability, pull the UAV when he wanted to, but then push it back. Very much like the Call of Duty game or some games your children may play, or you may play. But again, it was very seamless, very intuitive. And the lieutenant thought he was flying the aircraft. He never was, right? But the machine knew what it needed to do. And he was kind of just telling the machine what it already knows how to do better than all the operators. But what he was able to do is, on what we call fire and maneuver, he was able to clear his maneuvers with this stack of aircraft without having to type it back, because that level of interoperability in that digital age, we had kind of joined it for once. And then again, he didn't have to keep the aircraft with him. He could hand it back to that operator that was miles away. That's one example. And again, you can see the aspect of, as we pull on AI, as we pull on autonomy and automation, and I think they're all three different, you could help us just automate and use AI for our soldiers to to basically do their jobs in a far more capable manner. And I believe it's transformational. And so downstream, we even think we can have a smaller army because we're more capable. And we're doing those studies as well. So going back to the 4 programs, again, this is our big OODA loop. We have our studies, we have our sim, we go out west, and it keeps coming back. And that's to ensure we don't have this Comanche program where we have this billions of dollars poured down the drain and we only have 2 aircraft to show for it. Because some operational guy said, well, I want a gun that comes out in 1.2 seconds and is able to shoot. And we never needed that. But that's one of the design characteristics that killed Comanche. This very foolish, we want the gun to fly, on slew. And it gets after just, you would think we wouldn't be that myopic on some of these things, but at times we have been, and we can't afford to be in the future. And I would say the foot stomp on the digital age. Your Army is going to need to get into the digital age. We currently don't have any aircraft that have full authority digital fly-by-wire flight controls, which is the industry standard. And it's the industry standard across the militaries and in our civilian aviation. That leads to obsolescence problems where we're paying a premium for our current fleet because we're still stuck in an analog age. And again, just to re-stress to you, this body, is we're doing 2, not because we couldn't do 1 in the past. We're doing 2 because, again, our current fleets are bought out, and that's that 40 or 50-year buyout. And so when you think about the industrial base, we basically make vertical lift aircraft in 4 places. And the Army is the 800-pound gorilla in this capability space. And so if we don't do it, you're basically taking the nation from 4 places, Mesa, Amarillo, Stratford, Connecticut, and Ridley Park in Philly. You're probably going down to 1. And can we ever build that back if we walk away from that mid-decade? And again, not my job to make that decision. I think it's certainly our civilian leadership on the Hill and in the administration, but something we should be mindful of going forward is, I'm not sure we want to give up vertical lift industrial base to that degree and make that decision today. So with that, I'm happy to take questions on the program. And I think, again, I kind of have 11 use case technologies, and I could go through those in a different setting. I won't bore you with it, but one of those very prominent one is AI, autonomy, and automation, and that's where the tie-in with Dr. Maddie comes.
And actually, I'm not sure the online folks will hear us very well sitting here. So
Okay.
maybe you stay at the mic, and
I got a mic. They mic me
Oh,
up.
they do?
Yep.
Oh, okay.
So I'll share it with you.
All right, or I can stand at this way. Oh, there is? Okay. Well, while I look for that second Bombardier.
I think Dr. Maddie has it.
Okay. So one of the questions I have, and again, if you have questions, come on up or raise your hand and we'll call on you. The fundamental question I was wondering about is when I came here to Wisconsin, I came to work for an institute with NOAA. And while it did basic research, it was also geared at oftentimes requirements or impact. And so what is, and you talked a little bit about this, what is that overall balance between basic research, but a
Right.
need, hypothetical theorizing research versus requirements or impact?
No, that's a great question. And it's one of the fundamental things we looked at right away. And that's, I'll try not to go total Rain Man on you because it just ties into so many things. But if you know the Pentagon and you know the building and then how the building talks to Congress, we have a number of auditors at Echelon, as you can imagine, to make sure, again, our requirements are sound. They're going to be effective against our pacing threats, but also affordability, right? And the parametrics that go into the affordability question are decades old and arguable whether, you know, the folks that are auditors have gotten those right or wrong, but it's a very rigorous process. And so that's where we have tried to challenge the parametrics because of the digital age, which with a number of studies coming out of academia going, well, if you think about it differently. So the latest one said, you know, if 70% of your cost is O&S, here's the kind of premise that we think you can pull that down to 58%. We think that's your opportunity in this data, mountain of data that I talked about. So that's one example. And hopefully I answered your question, but very much that was one of our fundamental things is as we laid in our base requirements, and we actually didn't call them requirements, we called them attributes because we wanted to move them. If industry said, hey, not achievable, if the cost estimator said, hey, not affordable, we wanted to be able to flex them and find the most efficient, viable path. So again, I could go on and on because that's one of our fundamental first things is to prove to everybody, hey, we can do this and we can be effective, but at an affordable price.
We do have an online question from Dave Schrader. He is wondering, how can UW-Madison best help both short-term and long-term as an Army partner?
You know, and this is where, you know, it's chicken or egg. So Dr. Matty may, you know, for that question may have come up first because I think you'll hear from him. As we talk about, he talks about a triangle. And I'm going to steal his thunder, but, you know, he's talking about a degree program that's very much in the data realm. And then as I'm like a farther target away with research. And the Army's got these very wicked problems where your research folks could help us with this data management that span, you know, all the technical tasks I kind of laid out here to include our maintenance and our sustainment problem sets. So that research will be important because again, the feedback here is if I come up and it's a program that maybe isn't as respected as this. I mean, you guys are the best, if not among the best in almost everything we need done. That capability and that reputation isn't resident in the Army, and that's why we're here to ask for help. But when we go back to our auditors, again, both in the Army, the Department of Defense, and then Congress, ultimately, it helps to have people who are very serious and have a extremely good reputation to say, hey, here's what we saw as we helped the Army. Here's where they can improve. Here's where they're good. And then again, that outside kind of red team really helps the Army get it right. And then best communicate that to the folks that want to see what we're doing. Because they're writing the checks, right? And we owe that to them.
So can I just follow up on that? And then we'll go to you. Sorry, Eric. Because I'm wondering, we are the best at everything you need. So
right.
That aside, there are a number of people in the audience and online that work what I'll call as a small team or a faculty with DoD in general. What's the advantage between individuals working versus, you know, having like a center like CMU or some of the other universities that you had up here?
Well, I think it's on both ends of the spectrum, right? We might need a question answered in very fast fashion. So having that relationship, obviously with the resourcing that can be pushed, speed is sometimes important. And then obviously having a very long-term relationship where there's just good trust, transparency, understanding of where you're just absolutely the best and knocking it out of the park. I think that's good. But every now and then we need a question answered very fast. And if the relationship isn't established, it gets tougher to do because of, just resourcing it and then understanding each other in a fast fashion. But the bedrock too is important. So it's on both ends of those. And we have some of those relationships out there. But again, we need more bandwidth. I mean, these are massive programs. And I think the timing is right to come and ask for the help that basically we're asking for.
Yeah.
Thanks, Steve. Appreciate that. Thank you again, General, very much. As I understand it, the research that you would be asking University of Wisconsin researchers to engage in, or any of the other academics that I've come to meet, whether it's Carnegie Mellon or otherwise, it is not classified research. It's research that people here are accustomed to doing. Perhaps some of it would be classified. I don't know. So I'd like to hear from you on that point, but also when the research is being conducted, it is not solely for the military, but you're looking for applications that might have utilities with civilian use as well.
Yep.
Where the Army wants to be a customer to these technologies, not just an exclusive classified research. Could you speak to kind of those points a little bit?
Yeah, I think the majority of our work that we've kind of whiteboarded with some of the leadership is vast majority is unclassified. But I will come back to, you guys have a SCIF here on the university. Most don't. And so you have a place where we could do classified work, and that's, meaningful to us because we may get into the classified realms at times. And again, you guys understand more than anybody, just IP, we're locking it up tighter now because of just the massive amount of spying that goes on, even in our civilian industry. So we're encouraged by that SCIF being here. But like I said, there's a lot of dual use capabilities here in this space, from just the metallurgy to the mechanical engineering that goes into air vehicles, to some of the AI decision agents even are going to be very tuned to almost everyday applications. When you think about the ability to just maintain an aircraft or inspect the aircraft more precisely than a human can do it, that's compelling to us. And I think that would be compelling to the entire aviation enterprise.
And so if I can follow up on that while other people come up, and feel free to ask your questions or get them online. I'm sure that when you review at some point the partnership, that you're looking at the quality of the science and the research, the impact, the programmatic reviews, to what degree does it, do those reviews look at the products that were deployed into the public, if I will? So following up sort of on what Eric,
No, I think I would see just wide open in that. When we talk about networks, for example, and networks in austere locations. So we need to be able to talk in austere locations. And if we can do that, for example, on a more cost-effective manner and a more effective manner, I mean, that's where it goes and it impacts and transforms the civilian industry. We have unmanned air vehicles now that are setting endurance records, and they charge their batteries during the day, and then they can fly through the night. And we've tuned it, down to, minutes. Those unmanned air vehicles that are extremely efficient are flying capabilities that basically retransmit cell phone waveforms. Well, you can imagine that may be good for an austere location, may be good for an environmental disaster location where the infrastructure has been destroyed. And we're doing it at a very, cheap and effective manner. It's those kind of things. And again, it gets into those 11 use cases that I've talked about, very much promulgating into multiple dual uses, civilian and military.
So can I ask you to imagine now, 30 years from now,
Yeah.
when, we're not doing this anymore, but, some of the research that's going to support the vertical lift work that you're doing now, what do you imagine that impact is on the public? What would the public look like 30 years from now based on the activities you're doing here?
I think we're going to advance electrification, so obviously burning far less fossil fuel. And again, that's going to bleed into the civilian market. I think our research arm is going to help the electrification. I think it's going to help with the hybrid engine work, where we maybe need more power from fossil fuel at times, but less at other times based on flight profile. I think it's going to heavily offload our cognition in our cockpits. So our cockpits can be optimally crewed and sometimes uncrewed. So that optimal crew, we're looking very much at that. And it gets into what the machines can do better and always do better than the human. I hate to entirely throw ice water on it, but if we're going to fight, and obviously the Army is here to fight for the nation, I don't think we can go fully robotic. I think we are going to need soldiers in the future, because if the robots are hacked or gone, we may still need to fight. And hopefully we don't have to fight. We may still need to deter. I think on our medical side, when we talk about medical evacuation, it's only getting better with telemetry data and who we put in the civilian world on the edge to, and then how we get that patient back to a level of care that's appropriate. I think we'll know that to a far greater degree. We are the executive agent in DoD for medical evacuation. So in that medical space, it is important to understand from the patient to the vehicle and everything in that, you've heard it golden hour, but Congress has told me golden 15 minutes. So I think you're going to see a transformational capability there. The efficiency of the digital age, I would just tell you, when I was an aviation brigade commander in Korea, I had multiple variants of the Apache aircraft software variants on my flight line. And if you know anything about serving in the Army, you only serve a 1-year tour in Korea. So you have constantly new people. And we have all these software variants that require different maintenance. And we were messing it up a lot, as you can imagine, because our soldiers are very young and we give them great responsibility. We want to be able to park our very sophisticated aircraft in the hangar and over a long weekend, like a Tesla, get the software update. And that software update the simulators as well, and update the tech manuals as well. And so it's not only what the pilots do, but it's what the maintainers do. And again, I hope that comes through to the civilian world as well, that speed of the digital thread, and getting after some of these sophisticated systems that we can digitally update them at the pace of technology. That digital thread is going to be amazing. We are also, and I hate to go on too long, but it gets into the use cases, the additive manufacturing with very complex alloys. We're already doing it. So on our turbine engines, yesterday we had very flat compressor blades, and we had a lot of them to, again, compress that air, as you can imagine, and then fire off the turbine engine. Today, we're additively producing very sophisticated airfoils that compress at a much more efficient rate. So we have less parts in our engine, less things. We're digitally printing whole sections, and our parts count are going down by over half. And what that does, just to repair them too, because we're going to be able to put that one part back into the printer and it'll repair what we've eroded away, just driving the cost up. And one stupid story, the reason I'm here is the Koreans, when we're over there based on our agreements, built me an engine facility that I could repair my own engines. And so I would give back millions of dollars to my boss every year because I could repair my own engines. It wasn't because I was smart. It was because I could repair my own engines. Our engines are our costliest thing. And so I think, again, we see a lot of a lot of money coming back into the taxpayer coffers because we're going to get better and less costly. And that's where I want to be. I want to be more efficient. Anyway, I could go on, but I won't.
No, that's really interesting. Yeah.
We have another online question from Chris Kuzima. He's asking, beyond our faculty and research capabilities and delivering mutually beneficial outcomes, what capabilities do you suggest we have in our teams at UW-Madison to build and grow relationships with the Army? What unique skills and experiences do you recommend we staff within our team to initiate / build / grow / maintain productive relationships?
The big one's going to be AI, but I won't steal any more Doug's thunder. Obviously, we need aero and mechanical engineers to understand this. We need material science people. I think, again, we want to do it lighter and better and stronger, and those are wicked problems in the material science area. We want to understand cognition because we're going to want our soldiers to be able to fly longer and be more efficient in the kind of distances we're going to require from them in the Indo-Pacific. We want to understand the medical and how best to, in the back of our cabin, treat our sick or wounded. It spans everything. And I think, again, we want this data. And this is where Doug's going to talk, or Dr. Maddie, but this data, the Army has a hard time. We can collect it really well, but we don't know what to do with it. We don't know how to operationalize it. And when we talk about operational, this is no small bar that we jump over when we talk about the airworthiness. We need to go back to our airworthiness authority and with true outcomes say, here's how we could do it more efficiently with the sensor package, and then only give me my crown jewels. Let's not chase 1,000 points of light. Let's chase the cost drivers. You know, there's, you know, the engines, I mentioned them, you know, that's why I'm here. I did good with engines, right? I didn't do 1,000 things. I did okay with engines, and it saved us significant money, over 10% of our budget those 2 years. So that's the opportunity. And that really the AI, that's the piece, is this data that we have a problem with and then operationalizing it.
You want to ask one last question there, Tom?
One last one. Thank you, General, for visiting us here. We're very, very honored. Can you give us an idea of the time frame and the sort of, let's say, budget areas that you're thinking about so that our researchers can kind of put it into their context and think about it in the realm of the research that they're doing?
So the first unit equipped is really how I'm measured. The first normal operational unit that we equip with both aircraft will be 2030. And although that sounds like a long time, it's very fast when you look at the Apache aircraft and even the Black Hawk aircraft. We're matching those schedules that they did in the 70s. So that's the aircraft. On the unmanned systems, you'll see mid-decade, and as a matter of fact, you'll even see it sooner. Congress was very impatient with us, and we're actually doing it sooner. So you might see 2024 on a number of our unmanned systems and those getting out to the force. But what I would tell you is this open system approach, we can use help there too, because what that is enabling is a way to incrementally upgrade our aircraft in a far, more cost-effective manner, but far faster as well. And so it's the software and understanding software and the fracturing away our flight critical from our mission systems. And the airworthiness folks, they really get risk averse when we talk about our flight critical. And we could think 737 MAX, a very good kind of word picture to say, we don't want things that mess with flight critical and crash and hurt people. But those mission systems, how do we do that? And I think by baking that in, not only are you going to see work in the mid-decade and 30, but beyond that, our incremental tech insertions. We're going to hopefully be doing tech insertions at a far more rapid manner, flowing from our MOSA or modular open system approach effort. So With that
With that, I want
Look
to
forward
thank
to
you.
continuous
Yeah,
conversation.
really appreciate it. Yeah, turn it over to Kristen. Do the next interview, the next speaker.
If you could give him the mic back, that would be great. So I'm very pleased to introduce our second speaker of the Lunch and Learn. Dr. Doug Mattey is the director of the Army Artificial Intelligence Task Force, which has the long-term vision of becoming the Army's AI center. The organization is based out of Carnegie Mellon University in Pittsburgh. Dr. Mattey holds an earned doctorate in engineering systems from MIT. Welcome to Dr. Doug Mattey.
Thank you. Yeah, I guess I'm doing it here. Is that right? Let's see. Okay, so we'll go straight into it. Okay, good. Yeah, typically there's a divider slide that just gives you a second to kind of orient, so apologize. Thanks again for the opportunity to come see you. So this isn't my first time actually coming to Wisconsin. In the previous role I had, I was the deputy for the capability development group at US Cyber Command. And so it was at that time when I learned about the thousands of undergraduates that were coming out in computer science and the quality of the program, the fact that there was a SCIF that provided the opportunity. You heard General Rugen mention that. So a lot of the key aspects that we're looking for were already here. And so in fact, I came to this building, I think it's been 2017, 2018 timeframe. And I had a chance to sit here and meet with a number of the faculty and was very impressed with the work that was being done. And so really pleased to have the opportunity to come back and speak with all of you either in person or online today. So what I'll do is I'll just provide, and again, I don't mean to do death by PowerPoint, but I wanted to kind of share some thoughts with some graphics behind me to kind of reinforce some of the thoughts here. And so as the director for the Army's Artificial Intelligence Integration Center, it's really been about a 3-year journey. So as the DoD recognized the imperative nature of us developing and enhancing our artificial intelligence capabilities, we partnered with the DoD and the other services to say, how do we help accelerate this? And the key aspect that we recognized very early on was, even though we had already had a lot of folks that were in the Pentagon advising leadership about different decisions and resourcing and those types of things. And we had a lot of great work that was ongoing with our industry partners. One of the major aspects that we knew we had to go after was, how do we stay ahead of the curve? How do we ensure relevance with regard to research? And so as a result of that, the Department of Defense came to the Army and asked us if we would take the lead in that role and move and establish a presence at one of the leading universities with regard to AI, and that was Carnegie Mellon. And so I was asked to go up there and establish a foothold and see what needed to be done. And so the reason I bring this up is not necessarily to tout Carnegie Mellon's role, but to share with you a shared perspective. And that was, as soon as I got there and I met with the president, President Jahaney, and at Carnegie Mellon, I said, what do you think the #1 lesson learned from your experience in working in AI and autonomy and robotics is? And he looked at me and he said, Doug, you're gonna get what I tell you because you're in the Army. The #1 rule is you got to build a team. And so it's not sufficient just to have, a university. You have to have the best of the best, collaborating and working together, regardless of, what color their jersey is on Saturday, right? And so the key thing we did with our very first project was we reached out to other universities and brought that team together. And so University of Wisconsin is part of that initial project that we did. We started almost 2.5 years ago, believe it or not. And the way I tell folks is, you're on the team until you tell me you don't want to be on the team. And so we reached out, we had a number of discussions. The faculty from Carnegie Mellon that were the principal investigators worked with folks here, and we found that round peg to go into the round hole and said, this is where you can contribute. And since then, I think Starting from the initial first year proposal, we've actually continued to expand and build that team out here at Wisconsin to be partners, great partners, we see it as, on that initial project. So again, as I start to set the stage, the reason we're here really is to kind of continue and scale up those opportunities for us to collaborate, because I think that's a natural trait when it comes to, you know, researchers and faculty, is how can I better collaborate to advance our knowledge base and can make those contributions both to our military as well as to, you know, the rest of the nation. So what's our role? Our role is we are responsible for the Army's artificial intelligence capabilities. Now, when I say the word capability, for those of you that are familiar with DoD, we don't think just about the technology. We don't think just about that material solution, that box, that piece of code, right? It's not just about that product that comes out at the end of the research. We think about doctrine, which is how you think about employing these capabilities. We think about people, right? The Army's most valuable resources are people, right? We are a people-centric organization. And so for us, if you're going to have a new capability, as you heard General Rugen kind of share some of those insights about what the potential possibilities are with the various aircraft that he is developing, in tandem with that is what are the different skills, knowledge, attributes, behaviors that our future crew members are going to have to espouse and have on hand. And so we are constantly thinking about our people, organizations, facilities, right? So if I have an increase in terms of the viability of or how long aircraft can fly, do I need to have, as you heard, he built a separate facility that can handle doing engines in a fairly austere environment. And so those are all parts of the equation that we have to factor in as we think about these capabilities. But what I want to highlight today with you all is our focus on those people and the trainings and education that's required for those folks. And so we're chartered to really identify that for the Army. And if you believe what you read when you look at the National Security Commission on AI and its various reports, right, the Army's pretty much out in front doing this. And in fact, they very rarely do we have the opportunity for Congress to come and say, look, you're doing such a good job, we need to give you money so that you can continue and lead the way for the other services. So I think that you'll see as we walk through this, and I would love to have the discussion. I'm open to your questions. I appreciate your feedback. This is the way we're currently approaching it. And I'd like to have the exchange and see if there's something that we're missing or something we're doing better, or if you would just say we're doing a great job and we'll continue to push forward with that. So if I can, I'll go to the next one. I won't make you read all the words on the strategy slide. There we go. One of the key things I talked about this teaming, and to do that effectively, right? I say, so our chief of staff of the Army will tell you winning matters, right? We're in a very serious business, and that is national defense, right? Our commanding general, as part of is really the person in charge of the force modernization enterprise, recognizes that. So not only does he describe that winning matters, but he'll say, but winning as a team is even better, right? And for us coming out of Pittsburgh, as you know, right, great teams build winning legacies. And so that's the thing, that's the opportunity that I want to share with you today is how is it that you can be on the team? Because you're already on the team by virtue of being here. The question now is how do we find a spot for you so that you can make these types of contributions and build those winning legacies? And what we found in Pittsburgh is not only is it just the academics that contribute, but it's a lot of the after research. And the reason I show this slide to you today is you'll notice the number of the large, technology companies, right? So you can see on there, and I'll pick a couple. So GD is a defense contractor that's there. Amazon, right? Facebook, right? And I can go on down to Honeywell, et cetera. The interesting thing about this is those companies didn't move to Pittsburgh. They bought the spin outs from Carnegie Mellon and the University of Pittsburgh. And so it was through acquisition that those large corporations were able to maintain and continue their own innovation, leveraging the good work that the universities had. And so this is really, to me, kind of, if you ask me my long-term vision, what do I think success looks like? I would say I would take this map and potentially have some of these logos, excuse me, around Madison. Because to me, that's success, because we've partnered together. We've done the research. We've produced results to the point where now not only have we built a prototype or two, but we're now scaling it across the Army. And that's where industry comes in, because industry does the scaling in most cases, right? So I share this with you as a way to answer a question up front, is what does success look like? Again, I'll show you the Carnegie Mellon piece here. This is the bar. This is the expectation we have in terms of what types of folks are on the team, right? The good news is, and you already heard it from your vice president for research, is you're up there as well, right? In all the right areas. And so I need the slide, please. So I want to leave here so that when we get busy and we're doing a lot more work, I can show the next slide. But that's the idea. And the great news is it's been a couple of years that we've had these discussions, but I'm pretty certain that, just like an exponential curve, right? You don't realize it's exponential until you look behind you and see how far and how high you come. I think you're in a great position now, based on the series of meetings we've had over the weekend, that we're just about to hit that inflection point where we can look back and say, wow, I can't believe I've done that in a year. I can't believe we made this progress in the last 6 months. That's where we are right now, I believe. So what is it really we're talking about when it comes to workforce, right? So as you know, this is kind of a synthesis of all the best practices in terms of the teammates that you need to have on a data science team, right? I find it interesting that when I saw this particular article that they said, well, we're not only going to talk about the number one role, we have one that is just fundamental called data engineering. Because in the world that we live in today, if you can't get data, you don't have a project, you probably don't have a product, and you definitely don't have a chance for success. And so number one in our book, number 0 on the slide, is data engineering, right? You'll see the other list that's there. And so what we did is we call it troops to task mapping, where we said, okay, where do I find these types of folks, either in the military or in the civilian? Because as Joe Rugen mentioned, right, we have roughly 500,000 active duty soldiers. We have another 400,000+ in our reserve components. I have roughly 250,000 civilians across the Army, right? It's right around about 1 million, 1.1 million across the Army that we have in terms of our employees, soldiers, civilians, et cetera. And it's even more if I start rolling in the contractors. So the question is, where do I find the folks to fill out these teams? And what you see reflective here in highlights are those folks that we saw that we did not have in sufficient capacity to support the efforts that we needed to. And so that's what we're going after, right? And so it's no surprise, as I mentioned, to see a data engineer. It's not a surprise to see a data analyst, right? You heard about the manned, unmanned, optionally manned types of platforms we're going to have. So again, no surprise to have autonomous systems engineer. That's my upgraded term for roboticist, right? If you talk to me about a robot, I'm going to point you to a vending machine. I'm not interested in vending machines, right? What I do want is an intelligent system so that when I walk up to said vending machine, it recognizes me and gives me my Diet Coke without me having to ask for it, right? Now I'm starting to make some progress. So again, autonomous systems engineer, applied machine learning engineer. These are all the things that you would expect to see out of the Army, right? Because again, most folks tend to focus on the technical solution. If you look in the second column, I hope that you notice we also highlight that individual that's called the ethicist, because it is fundamental to our ability to produce capability that we can assure our soldiers, our civilian leadership, right? Because everybody understands that the military works under civilian leadership and control, and our most valuable stakeholder, which is our public, right? All of our citizens of our nation, that they can trust, that they believe that what we're doing is ethically, legally, and morally correct in terms of how we are employing technology to affect the outcome of the missions that we're being asked to provide, right? And so that you'll see later on in our framework that how prominent a role ethics plays. Now, as you think about this, how does this transfer over to our work roles? How do I categorize that? And so no surprise here, it's kind of a tiered approach. And I know most folks look at this And if you have any familiarity with Pittsburgh, you'll be focused on the Golden Triangle, right? Because that's the nickname for the city of Pittsburgh, right? But what they don't realize is really when I talk about the Army, I'm talking about the square. I have the prominent role of informing and educating the Army's leaders. Who are the Army's leaders? If you ask me, I will tell you that everybody in the Army is a leader because they're either in a leadership position like General Rugen, or they aspire to be in a leadership position, whether it's squad leader, whether it's platoon sergeant, whether it's company commander, and so on. And so our key aspect that you see on this chart is that we are developing those leaders that understand AI, right? They understand the employment of it. They understand the ethics behind it. They understand the technology to such a point that they can discern the difference between having data, which as you heard before, we have lots of data, but they don't know how to operationalize. Why is that? Because they still haven't understood the concept of curating data. What does it take to really label data? What does it take for me to effectively manage data? And how do I deal with data security, privacy, all those other types of considerations? And so we have a pilot course that we put together, you see on the top right of the square, called Data Driven Leaders Course. And we walk them through that. Currently, we have it spread out over the period of a couple of months to allow them to digest it and work on some projects. We're now going to start moving to a different format where we pull that together and then have them in person. Now that we've achieved that we think we can sustain this model, have them come together and work through an intensive week-long program where we present these types of approaches and give them the tools and techniques that they could take back to their organization and apply them. Right now, I'll start to focus on the triangle. And so as you have no surprise there is, right, we have a professional level. That's what we talk about, the tip of the triangle. Currently, we have 3 programs that we are either piloting or are about to initiate. One is focused on data analysts, right? The second is data engineering. And the reason for that is because the Army has tried for the last decade to field data science, right? We have not achieved success. And the reason for that, and I'm sure that most of you will know this, is I can train folks and put them through a data science program. When they hit the workforce, they will undoubtedly spend 80 to 90% of their time doing the work of what would be called a data engineer. And so why would I put all of that extra burden onto someone who I really have trained to do mostly what we call data analyst work? And so from our approach, I say data science equals data analyst plus data engineering. And I have, just as I do with a lot of our capabilities in the Army, they're crew served capabilities. And so I have a gunner and an assistant gunner, right? The data engineer is going to make sure the data is flowing, and then data analysts can write all the visualizations, all the algorithms that they like, right? And we'll talk a little bit more about that. And then the third one is the autonomous systems engineer piece that I described. Again, we have several programs that have generated robotics, right? But it's time to upgrade that approach. And so that's why we're going after a pilot effort for autonomous systems engineer at the professional level. Now, those are the folks that will generate a lot of the capabilities that we're looking for. But again, I'm not just only in the business of generating new thoughts and new capabilities. I have to actually operationalize and implement them. That, for those of you, I grew up as a double E computer engineer. My favorite person in the world was my electrical tech, right? Because I could go talk to them and they gave me very grounded, straightforward feedback and suggestions when I was trying to solve problems. And voila, things would come out from the lab that they would say, here's your circuit board, here's what you need to do, here's the next thing to try. And so we have that similar type approach in the Army where we call them master gunners. So they're not only the most proficient on any given capability, but they also understand a whole nother level of technical expertise that they can then transfer and teach others how to use those capabilities. And so that's the model that we're employing there with the AI technician. That's really our center of gravity for our workforce, right? It's very common that you find in other branches, we have warrant officers, they're somewhat called technicians as well, right? They, no kidding, know their platform, they know their system. That's who you go to get all of the experience and insights from. We're going to replicate that type of work role with our technicians. Again, it's a currently it's their technicians program is roughly 6 months long of education with 6 months of hands-on training and experience on projects. We started off with 3 certifications. First was like a general cloud architecting certification, followed by a specific one on a given platform, right? And we can vary it between Azure, AWS, et cetera. And then the third one was just, again, more of an advanced cloud architecting certification. We started with that last year as a pilot. This year, we are adding some additional skill sets to our technicians training. They'll end up, the result is they'll have 6 various corporate certifications that they'll have, right? So again, continue to work through the technicians piece. And as I mentioned, they'll be the trainers for our other use case here with the AI users course put together for that is, as we start to field the systems and capabilities that General Rugen mentioned, I'm sure one of the results that those program managers are going to have is what's called new equipment training packages. So here's how to operate, here's how to turn on the engine, here's the button you push to calibrate or bore sight any capabilities that may be mounted on it, you know, step-by-step instructions on how to operate said piece of equipment. But since we don't have those, I don't want to wait, right? We already are anticipating the difference between these AI-enabled capabilities or systems and what were closed systems of the past. And so we're starting to share some of those insights now through this AI users course, because those soldiers, whether they're E1s to E4s today, O1s to O2s, you know, lieutenants to captains today, right? When these systems come online, as you heard in 2030, they're going to be those majors. They're going to be the platoon sergeants. And I want to ensure that I have leadership. If you think about it, those folks at the bottom that I'm training, the AI users, that yellow will start to permeate the rest of the square. That's really the goal that we're trying to do there, is fill out the rest of the square with that gold, i.e. the AI information and insights that we need to have. And again, I mentioned earlier about capabilities. You see the acronym again. I don't want to flood you with the acronyms about putting together the training. That's what the capital T is: training, leadership, and people. Now, moving forward, when we think about AI, we don't think of just the algorithm, right? There's a tendency for folks, when they talk AI, all they want to talk to me about is machine learning. That's just one aspect of a full set of capabilities that we have to put together. Now, this is kind of a slight variation, changed a little bit of the terms from what CMU had originally espoused a few years ago. But based on the success we've had in terms of helping it to frame the problems and move forward, we're seeing this replicated now by both the Navy and the Air Force. They're starting to adopt this mindset because it resonates with DoD. Because again, it's not just about that one aspect. Just as I talked about .mil-PF for capability, same thing with AI systems. I have to think about how much computing is necessary. Am I doing it at the edge? Am I bringing it all back to the cloud? How am I going to manage all of that data? Do I need all of it? Or can I get along with just, you know, either the data that's streaming or some subset that I can use for decisions for localized situations? All of these things tie together. And what you see here is just kind of a rough mapping, if you will, of where those work roles really tie together. So we've essentially chosen the basic core elements of a team. You saw a much broader set that we look to bring in, right? But I already have those. I can go to a software engineering center in Huntsville, Alabama, and find all of the support that I need for software engineering. If I need folks that are doing behavioral psychologists, there's a place called the Army Research Institute, or ARIs. They do all of those sociological, psychological studies on soldiers. I have folks I can ping. What we were focused on is really those gaps that were identified and how do I go after them and bring them together. And we do it to help ensure coverage across the broad spectrum of what it takes to have AI capabilities. Now, what does this mean in terms of the program? We started off with roughly 12 to 15 technicians. We had 10 data analysts, 10 data engineers, right? And the idea is that we were going to build these data science teams, right, that are cloud enabled. That's where we're trying to go. Now, we're going to increase that as we start to mature these efforts. So we'll go up in terms of numbers of those. You also see in the second bullet that we're going to add our autonomous systems engineers, because now that I have my training environment to take care of those things in the cloud, now I'm going to start pushing things to the edge. You heard about operating in austere environments. You heard about working with communications that are degraded, whether they're intermittent, right? All types of aspects on those. We're going to make sure that we operate both at the rear as well at the edge. And those are the things. And then again, the key thing that I had from our chief of staff was, he said, look, he goes, we need to have the world's best. They have to be able to support this anywhere across the world. So go get me, 8 to 10 PhDs. Well, as you know, you don't just go and find candidates that can do, original research. Right now, we have a number of smart folks in the Army that can go get PhDs at tier 1 institutions. The challenge that we have is you only get 3 years to do it. When I say 3 years, I mean 36 months. And so I don't know what the average time here is for a PhD. I know at MIT, it was roughly 5.5 years. It's Carnegie Mellon's about 5.5 years or so, right? So the question then becomes, how do I get PhDs in 3 years when you're telling me it takes 5.5 years? Well, the way I do it is through teamwork. So I'm going to send you those folks at the master's level. And the program that we've selected to send them to are not terminal degrees, meaning they're more research-based master's programs. And to allow us the opportunity to do those, we don't do the 12-month or the 16-month program. We typically send them for 22 months. And we require that they have at least a capstone or a master's thesis that they work on and produce as a result of that, to demonstrate and start to build some of that research capability and understanding of the process, right? I would almost argue that ideally, I'd love to see them leave their ABD. And I've done that in other universities where I've sent folks for master's degrees and they left all but dissertation because they've completed the coursework. They go out to the Army and apply what they've learned in the classes and then come back. And now they have 3 years to work on their dissertation in original research. And they knock it out of the park. So that's really kind of the flow. And so I'll just show you up at the top right, you can see, the timelines that we have for our folks. PhDs, as I said, 36 months, they go through school, then they come to the center and we get to leverage them for a utilization tour, if you will, for 36 months. Likewise, the master's degree, it's 22 months. We send them, they come to us for 2 years. That's shorter than most ACS programs in terms of utilization. Most of the time, it's also 3 years. What we're also trying to do is we want to make sure that they are viable in their basic branches. There's a lot that our officers have to do to maintain operational relevance. And so if I keep them that extra year, I'm probably ending up hurting them, and by keeping them away from the force. And so by curtailing it that 1 year, they have enough time in that 24 months that they work with our cadre or the research faculty, where they actually understand how to build these systems, how to field these systems, how to produce something that is viable as I'll say beyond the minimal viable product, and actually get to something that might be usable. And then I send them out to the field, and they, without a doubt, so far, they've been doing the same thing in the field. And again, with the technicians, there's a utilization time that we have just to make sure that they've got hands-on experience in building real systems, not just the academic part of it, right? And what you see in the bottom right, that's our growth over time. So how are we maturing the programs? You can kind of see where, with the technicians, I told you, we start off with 12, we bump it up to 15, we'll hit a steady state there at about 20. Our academic scholars, we start off with a pilot based on 3 questions. One is the Army right for this program? It wasn't a sure thing when we put folks in to, top tier master's programs. Could they actually complete those degree programs as they currently were, right? So far, with the second cohort finishing up their first semester, one cohort on their second year. Right now, the response we got from the faculty at CMU is, you guys are rock stars. So we've answered the first question. The Army's right for those programs. Now we're asking the second question, which is, what are the right programs for the Army? Just because I have a top-rated program doesn't necessarily mean that that's the only program or a perfect program for us. And so that's part of the dialogue we want to have about what should constitute the program of study for these master's programs, et cetera. PhDs obviously are a little bit different. Those are nuanced and tailored for the individual. But at least for that master's program that sets them up for success, we want to have those kinds of discussions, right? And we'll continue. And then the third one is, how do I scale it? That's why we're here, right? So I look forward to the partnership that we have, whether it's Carnegie Mellon, University of Wisconsin, University of Southern California, University of Texas, Austin. I mean, all of the similar schools that you probably are working with already, Georgia Tech, et cetera, you're already collaborating with them. All we're looking to do is leverage those relationships and build upon them, right? All tides raise all ships, right? Rising tide. So that's kind of the good news that we have with that. The next thing that you're probably asking about, okay, well, tell me what are the problems that you're interested in? Well, General Rugen mentioned about the problem sets that he has specifically in his cross-functional team area with the future vertical lift. We cut across all the cross-functional teams, right? And so what we've learned is rather than pigeonhole ourselves to, any given framework on how to decompose that, I basically took the joint capability areas that are exhaustive of all the work that the Department of Defense does. And I've laid those out as the portfolios, because now I can map to not only the work that we, the Army, are doing, but now I can explicitly partner with my sister services. Again, if you're out in front, you got to be ready to help your folks on the left and right. And so I'm happy to bring the Air Force and the Navy along with me, the Marines, et cetera, Space Force and such. I'm happy to bring them along and show them what right looks like when it comes to AI. And I have a framework that allows me to do that. Right. And I noticed the dean's already getting ready to ask me the question, well, what's that other portfolio that you have on the top left, where I've defined it as basic research? So you had a question earlier about how do you discern the difference? Is there any goodness out of basic research? And the answer that I would give you is a resounding yes. Because if I'm doing the right kind of research in those respective portfolios, I'm generating more and better questions that I can't answer because they're more fundamental in nature. And so I like to take roughly 25 to 30% of my budget and I put it back into basic research, because that's the only way I stay ahead of my competitors and adversaries. And so it's absolutely essential to have folks working together, because again, I understand faculty. Some faculty love to do applied stuff, right? They're looking to find Eric and say, hey, you ought to see this thing that I got, and how do I get it to market, right? And there's other folks that sit there and say, you know what, there's a really good question that nobody's been able to answer, and I'm going to keep working at it, because someday when I get that breakthrough, it's going to be phenomenal. But I have a lot of really good insights as I work towards that objective. And if we work together, a lot of those insights will feed those other folks, that the other folks are like, here's how I can spin this out and put it into something that General Rugen can use tomorrow. Right. And those are absolutely key types of dynamics that we're looking to have in our effort. I know most folks focus on the left hand of the slide, but for this particular audience, I just want to touch on the portfolios and that relationship. And the key thing that I would just say to you on the stuff on the left, just so you know why I even show the slide, is we've already codified these in what we call additional skill identifiers. And so now from a human workforce management perspective, I know exactly everybody that's done this, even though they may be infantry or aviation or a geospatial analyst, et cetera. They have this additional skill identifier that allows me to tap out to them and say, hey, I have some work for you to do. And I know you have the skill set, and it helps our commanders track them as well on better employment and how they leverage those talents when they show up in their organizations/units. Right. And again, we're trying to field an army here. And so you can see on the left side, those increments go up 0, 200, 400, 600, 800, et cetera. Those are the quantities of the numbers of folks that I'm looking to generate cumulatively, right? And this doesn't have the AI users, because with the AI users, when I put those on, 400K is the number I'm shooting for, right? That's the scale that we have available for folks. And that's something that we can do in partnership with universities as well as community colleges. Have it locally. We'll send our technicians out. They'll facilitate it, and the faculty or instruction can be provided remotely through distance learning medium, et cetera. Right? But that's kind of the key, is we're really trying to generate and have an AI-enabled workforce as well. And the last thing I'll show you is how do we pull all this together? You asked the question, what are you part of? This is the core of the team that we already are generating and building. And what I tell folks, when I talk to the industry folks, the first question that I'll ask them is, when are you putting your office in Pittsburgh? And the reason I ask that is not because I'm part of the business development group for Pittsburgh. The reason I say that is because remember that team structure that I showed you with the 19 different roles? I need you to be there to help coach, teach, and mentor my young graduates, the scholars, technicians, et cetera, and work with them, right? Best practice is to be embedded with your partners. right? And so that's what we're looking to do. That would be the model that we would look to do here as well. And so our scholars that are here getting their masters, right? I will be pointing any of the industry folks that say, hey, I want to work on that project with you. Great. Where's your office going to be in Madison? Because you got to be right next to these folks. Or in some cases, I understand you already have industry partners moving into the facilities. So again, you're already ahead of the curve in that regard. So you'll have folks right there and they can partner up and do the work that we need you to be done. So I applaud that effort, right? I think that's the last specific point that I was going to share on the slide with you. But again, I think we'll have a chance to talk through and discuss some points and potentially even address some questions, and I'm happy to do that. Thank you.
So again, if you have questions, come on up to the mic here so people online can hear, or if there are questions online, Laura will go ahead and read them out. And you coming to take a picture or a question? Oh, turn on the mic. Audio guy. So while you're turning on the mic, I will note that I think probably some faculty get scared when they hear about a PhD in 3 years, which can be a challenge. But I'll also note that the Air Force also has a program like that. And we've had PhD students come through our department doing that program. And you're right, it's really you need that infrastructure and that attitude of this can happen and away we go. And they're very motivated, the ones that we've had come through our department.
Yeah. So again, my experience, but I don't know if folks can hear me. So my experience was 36 months and 4 days, right? So I mean, I was tracking it that close.
So you're late.
I was. I actually, because again, the Army, and I say this jokingly, decided I needed to go to a real school. So I left Cambridge and went to the Army War College in Carlisle. But the good news was I was able to schedule my defense on the Friday before Labor Day. Very strategic part on my part. And so I was able to go back and do a successful defense there, and then finish up writing it while I was working there at the War College. But the point is, as I said, I think we have to think differently about it. The Army and this other services, remember, we're thinking about a 20-year career, right? There's not a whole lot of time, especially if you're thinking about more than a 3-year time frame to let someone go off, and they've probably already have gone off already for a 2-year master's, right? So that's already 5 years in the services mind. And so to let them go off for a 20-year career, because that's the definition of success, is 20-year retirement, and potentially for commissioned officers, I'd say a grade of 05 or lieutenant colonel. That's a big investment. So that's why, as I've gone and talked to other universities, and I've had this discussion here in the past, I think you need to be creative about how to do that. And that's why I say is if they come in and they have a strong master's program that is research focused, you've put them on a good path to do essentially like we talked about an ABD. In fact, I've had some universities say, look, we'll just admit them to the PhD. They can come in, they can take their coursework, get through their generals if it's in a program that requires, qualifiers, et cetera, and they can leave and then come back when it's time for them to do the research. Well, the challenge with that is the Army will give you 5 years, up to 5 years to finish your PhD, just not on site. They'll let you stay there for 36 months. And then like I did, I had to move to my next duty station, right? It's incredibly hard to finish a PhD when you're working your day job in the Army, especially when it may involve being in other countries, doing lots of other things. And so that's why I think having that split that we're talking about, where it's 22 to 24 months, masters, right? Give them the master's degree, and we can construct that program of study so that it sets them up that when they do return, they're already ready to go and hit the ground running because they're familiar with an area of research. They've kind of, fine-tuned their lit review in a sense and ready to contribute.
Yeah, and I think a lot of times, so they often come in with a science problem in their mind as they hit campus right away. So it's pretty valuable.
Plus, they don't have to remember, we're in a lot of cases, they're fully funded. So they're not necessarily looking for TA
Right.
types of opportunities. So they can really focus on this. And then the other thing I would offer is, most of the we're picking folks a little bit younger than typical. So like your typical Army officer that you may have had come back on an ACS program is around, I'd say between 8 to 10 years of service. So they're roughly 30 to 32 years old. For our folks, we're picking them just a little bit younger. So the trade-off there is whatever they had learned from their undergraduate times is still a little bit more fresh, right? But at the same time, they're still very mature, right? They've done a lot of time as a company grade officer. So you have the maturity, you have the motivation. I have yet to have someone come to tell me, and I used to run all of the education program for the Army's operations research functional area. And I have yet to have anybody come back and tell me, hey, this guy doesn't really want to do work for me. I'm not sure they're going to make it. Never happens. In fact, it's usually the opposite, saying, hey, can I just keep them and let them finish this PhD because they're on track. So,
Yeah, question?
Thank you for your presentation. I really appreciated that you described the importance of ethics and legal facets of autonomous systems and AI through all facets of research and application. I have two questions. One, how do you do that? Like, how do you incorporate ethics into all facets of AI and autonomous systems? And where, related to that, where does that show up in, for example, CMU's program or other programs you might be contemplating?
Sure. Yeah, thanks for that. So it's absolutely essential. And again, I highlighted it on the one slide, but I think is to your point, you saw it on several slides. So ethics runs pervasive across from all the way from the users up through our professionals and including our leaders, number one. Number two is it's also on the AI framework. And as you saw, it goes across. So one of the things that we do is we specifically leverage. So again, as Army officers, we as commissioned officers, there are specific guidelines that the law of land warfare. There's a number of legal implications that they have to be trained on. They have to understand that. It's more than just working through what we call rules of engagement that impact how operations are done. And so for us, it's a very natural extension to start thinking about, well, if I now have a system that has been trained, and we do this with our soldiers. General Rugen is responsible, as he talked about when he was in command of an operational unit. If his soldiers made bad decisions or unethical decisions, he was ultimately responsible from that command presence. And so for us, it's a very natural extension to say, look, instead of training a person, now I'm training an algorithm or system. And so I am responsible as the developer of said system to ensure that I imbue ethical and constraints with the legal implications, those types of behaviors and performances. And it also ties in, that's the biggest part of our work on the T&E side, or test and evaluation, right? Is we still have to take things through a very rigorous test and evaluation process. And in fact, that's an area that we could definitely use help, because the folks up at the DOT&E, as we call it, the Department of Training of Test and Evaluation at the DoD level, the folks in the Army Test and Evaluation Command, they're actually coming to us to join our group to say, we want to work through this with you, because if we wait until you've developed AI capabilities and then try and test it at the end, not only will you fail, but we will have failed in our T&E policy, oversight types of responsibilities. So, I mean, it's a very active area to work with, but a lot of times, again, folks come to us and say, well, how's this going to square with the Army? Because, there's so much chaos and so much uncertainty. How is it that you can't just say, well, ends justifies the means? Well, I will tell you, from the time that you're a cadet as a commissioned officer till the time that you're a general, you are constantly reminded, because you are in fact responsible for all of those ethical types of dilemmas and situations and working through to make sure you make the right decisions. So it's very natural.
Interesting.
I have two things. One is, I just want to mention, we'll be making the slides and recording from today available, and we'll send out the link to that to everybody here and online soon after this. But also Dave Schrader has a question, which is, what is the breakdown of undergrads, grad students, faculty, researcher working on programs at CMU and any other partner organizations you're working with?
Sure. So undergrad is a much broader set. So I'm working now through the new commander at what we call Army Cadet Command. That's where all of the ROTC program runs through. And so we're having those discussions to see how we can help them not only enhance those folks that are going, but understand exactly who's doing what, where across the multitude of universities where we have ROTC programs, et cetera. But with regard to the programs we have, again, as I said, we're just now, I'll say, kind of transitioning from that pilot phase. Now that we say, okay, this is the level at which I know our officers can compete in terms of the scholars level. And it said, you know, I had a meeting with all of the AI technicians. And of course, you know, they're very thankful for the first cohort, because the first cohort kind of gave us the feedback, said, hey, this was almost too easy. We can do more. Right. And so now they're feeling the effects of that gift that the first cohort gave them, where we added a lot more to the curriculum. And so they're saying, hey, this is really, really hard. But again, that we're still fine tuning those pilot efforts. So I don't want to say that it's a split in this regard, but if you look at our numbers, it's no surprise. We have roughly 20 of our military scholars going through the master's program, because I fully expect them in about 4 to 5 years to be coming back then to start their PhDs. Not all of them, obviously, but it's about a 1/3 I think will be carrying forward. So we think that's about a good number to expect a return. And we'd see something like that similar as we scale across other university partners.
Great, thank you. Great presentation. I actually have two questions.
I'm sorry, I should have said this before too. Could you say who you are?
No,
Yeah.
Eric Wilcox, Dean of the College of Letters and Science. So welcome to both of you. Two questions. One on thinking about the PhD side of things and thinking about how typically a PhD thesis is defined and developed. Is that something you're looking as a collaboration between what you need in the interest of faculty, or is it a problem that you have stood up and saying, boy, here's a student, we want you to tackle this problem, and we're looking for an institution where that's going to fit? That's question number one. And question number two is somewhat unrelated. You've both talked about a lot of data. I'm wondering about the development of the sensors that generate that data and how that fits into what you're thinking about.
Sure. So I'll take the second one first, if I can. So obviously, as we think through the stack, sensors are explicitly identified as one of those components. And so we're always thinking about that. The challenge we have is a lot of the things that we're looking to embed in terms of infrastructure to support AI at the enterprise scale. There aren't necessarily the sensors already established in a number of our platforms. And so as you heard before, we talk about the problems for the here and now versus the problems in the future. I trust General, he'll have all the sensors I need to do all of the predictive maintenance, types of efforts in the future. So he's got that. The challenge we have now is, what do I do about these older aircraft? As you heard, the analog versus the uncensored, things like where I have to go up and stick a thumb drive in to try and download, data, et cetera, because the telemetry doesn't exist. I mean, those are the challenges that we're looking at in terms of the sensor piece, but that's only one of the components. Now, the broader question that you asked first is, I would articulate and say, I always look at the three legs of the stool. And so for me, there has to be a three-way win for you to have a sustainable way ahead, right? Because I can come up with a really good idea and I have enough folks and resources that I can say, yep, this is what we're going to do. And I'll find some school that'll say, yeah, whatever you want to do, Maddie, let's do it, right? That's not a good way, right? And I could probably come in and pitch something that it sounds really good, and maybe you or someone else will buy off on it and say the two of us are good. But the question is, what's that third leg of the stool that says, it's an independent view that says, hey, actually, that is a really good thing. So the three-way win is a must. Where I see the three-way win with regard to the PhDs is we together have defined a number of technical challenges that have to be addressed. So I have tons of problems, right, that I need folks to work on. In fact, as I mentioned before with the workshops, as a result of those workshops, I got 120 white papers that came back from academia that said, hey, we think we can help you in those areas and we can get after those types of things. The challenge I had at the time was, since we were so new, we hadn't gone through any of the iterations of the resourcing cycle that the Department of Defense is infamous for. Right now that we're a couple years down the road, I've addressed that, and I have some resources available that we can start to find those opportunities. So the nature of the research, the problem statement, if you will, we can get after. For the faculty member, that's absolutely essential because they want to work on interesting problems. I don't think you're going to find either technically or operationally better problems than the ones that we can offer. Two is I'm going to offer up our best and brightest. So, I mean, I'll just give you, so some of the qualifications on the folks that are doing the data engineering program and the data analyst program right now. I mean, predominantly a lot of them are from West Point because that's where most of our STEM officers came out of, right? Folks that go to other schools tend to be more interested in political science or international relations, those types of things. Nothing wrong with that. I'm just saying that they chose to go somewhere else to do those studies. But most of them are about a 3.7, 3.8 GPA out of West Point. Their GRE scores are roughly about 162 to 170 in the quantitative skills. So I think they're fairly competitive to get in most of the programs that we're trying to put them in. So they're getting great students, motivated, mature, as I described. And so I think when you have faculty that are interested in doing relevant, viable research, pair them up with a great student, and then you pair them up with a really good project that comes with sufficient funding that they can have, the resources and things that they're looking for, I think that's a winning combination.
Thanks, Doug. Let me again say thank you for being here. It's also, as a private citizen, it's really heartening to know the military is thinking about this from a very intellectual, cost-saving, but people first perspective from the military. So thank you for that too. I have a question that extends a little bit from Eric's. I'm thinking about it from a continuity as well as a logistics point of view, and really looking at the AI technicians as well as the master's programs. That's where my question is based on. And one is on the continuity perspective. Is the curriculum for each of these the same, regardless of what institution, or can each institution tailor it a little bit to suit their perhaps areas of focus or strengths? And then second, on the logistics, how do you select which one of these schools any given person is going to go to?
Sure. So, so with the question, I think there were a couple questions there. So for the technicians, I think that one will be fairly symmetric, regardless of the institution. And that's one that, but that's not to say that it's static, right? I mean, it's part of the reason why we want to incorporate other universities, because we want to have a better dialogue and a more informed dialogue about what actually is necessary for those technicians, and as well as for the masters. For the masters, I don't have an expectation that it is a cookie cutter kind of thing, right? I think that there's congruence that will be natural amongst those things, because again, we're focused on having someone that can do relevant research focused on in an area, but geared to producing someone that can do that particular work role, whether it's the data engineer or the data analyst. And that's why I say, I mean, everyone's familiar with, you draw your sample space, right? And there's the two circles with the overlap and the Venn diagram, right? We actually encourage the fact that there's probably a good amount of overlap between that data analyst course that we have and the data engineering course. But what I do emphasize is the fact they can't be completely overlapping. There has to be sufficient spread to pick up those other things. That's why I showed the chart on the stack, right? Is if I have folks that are focused on doing, whether it's the database work and the data management, then I don't want them necessarily spending all of their time, because again, 22 months sounds like a lot. When you talk to the students, they're feeling it, right? There's not a whole lot of time to go take all the other electives. And so I don't want them necessarily worrying on the UIX piece of that while they're at school. Now, that doesn't mean they don't, I got lifelong learners. So I can't stop them from doing more other things, right? So I think that that's an important part of building a robust thing. That's why we had when I set strategic thrust for the ops research community, we built big data, right? And so the idea behind the big data was, I said I wanted folks that could do the pure data science, but then I also found a university that was specializing in cyber systems engineering. And so I gave up a couple of folks. Instead of having all pure data scientists, they went and picked up cyber systems engineering. And then some of them went off to study network sciences, because I knew that that was another facet to cyber that we were looking to get after. So I think that there's room to have that discussion. The key thing is we want Wisconsin to be part of that discussion. And I think that your position where you can help lead that discussion. So, yeah.
Great. Well, I see Kristen's getting up. So thanks again. It's been a lot of fun. We'll have more discussions throughout the afternoon, I guess, about particularly with regard to the education program. So great. Don't go. We have a couple closing remarks here, right?
Yep, closing remarks. So I have just a few closing remarks, and then to remind you, there'll be a 15-minute break, and then there will be a breakout session where we can continue the discussion, have more informal discussion, more intimate Q&A with our guests. That breakout will be in the orchard room on the 3rd floor. To get to the 3rd floor, if you don't have key access, you need to take the stairs or the elevator that's over by Aldo's, so the far east stairs, not the stairs in the center. That's the key card one, unless someone's holding it open, of course. Okay, so going back to the more research portion of our talk, you may be wondering, oh, this sounds really cool. How can I do this? Like, how do I actually create a research agreement with a defense agency? So I have great news for you. There is a mechanism. So last year, University of Wisconsin-Madison joined an academic consortium known as Ensure. Next slide, please. So the Ensure Consortium offers a streamlined access to new collaborations and projects in order for you to get research funding provided by defense and intelligence agencies. So the whole purpose of the consortium is to bring together university researchers from different campuses to work with the defense and intelligence community to do research in the national interests. So it's ideally brings together a really diverse set of university experts from across campus. And of course, it provides funding for many research areas. And perhaps it's very on theme today because AI, analytics, and machine learning are one of those areas, but other areas include the social sciences, languages and culture, engineering, life sciences, and computing technologies more generally. Next slide. So it is a consortium of universities. So this slide is actually a bit old. These were the members about 6 months ago, but since then, I think Illinois is joining, St. Louis University is joining, a few others are joining. So it is an evolving cast of characters. But what happens in these Ensure meetings is that an intelligence or defense agency will come and pitch a problem, and they'll give a talk talking about the problem. And as a consortium member, you can join those pitches and you just watch and think, oh, could I contribute anything here? And then the consortia acts as a coordination point, and ideally, again, pulling researchers from across different campuses that are members of the consortia to develop research teams to tackle these problems. Next slide. So again, why would you do this? You would do this to identify new and interesting areas of research. These are all very real world problems, like the ones we've heard, described today. They're problems that are affecting people right now that need fast answers and need solutions. This is a great opportunity to fund additional research. It is a mechanism to accelerate and streamline access to research funding. The means by which these research relationships are set up are different than what you would normally expect through an NIH or an NSF grant. It's more, you have more conversation beforehand. So by the time you get to the point of actually putting together a full proposal, you kind of know that the marriage is going to happen versus a more formal granting agency. You connect with potential collaborators at other campuses, develop relationships, etc. Next slide. So again, broad variety of content areas. Most relevant for our Lunch and Learn today, of course, is the information engineering, advanced computing, and AI and human performance. But I've sat in on a bunch of these talks, and I assure you, there are a lot of really interesting human and social systems problems that get discussed. There's a lot of opportunities for the social sciences and languages here as well. Next slide. And this is not all classified research. In fact, most of it is not classified. So if you don't need to have any kind of security clearance. In some cases, some projects do require you to be a US citizen, but not all of them. So these things can be worked out on a case-by-case basis. And the consortia staff can also help you figure that out. So bottom line, it is totally possible to participate, collaborate, and receive grants without doing classified work, needing a security clearance, or even being a US citizen. So the way these insurer meetings work is you have to show up and listen to the pitch, or and how do you find out when these pitch meetings occur? You get on the email list. So we don't have a better way of doing this than an email list right now, but we have an email list. And so we're going to send around a link to a Google Sheet where you can get on the email list, and then we will forward these invitations to you. I warn you, the descriptions are written by the folks from the defense agencies and the intelligence agency. So they kind of have a lot of jargon in them. But so you kind of have to kind of dig through to see the problem underneath it. But I do encourage you to come. The pitches are really interesting, and there's a lot of interesting work and research opportunities out there. But if we were interested in having a research relationship with Army, the Insure Consortium would provide an administrative mechanism to help facilitate that actual relationship. And I think that is the end. So thanks very much. Please enjoy your break and join us in the Orchard Room at 1:45, where we will begin the breakout session. Thank you very much to our guests today. Let's give them a round of applause. Thank you.